Thank you everyone for tuning in or watching our video. We are group number 2. My name is Levi Hamby. I'm a mechanical engineering student here at Western Illinois University.
And my name's Allison Antalik. I am a civil engineering student at Western Illinois University.
My name's Sydney McDaniel. I'm a civil engineering major at Western Illinois University.
Hi, I'm Gavin McGuire. I'm an electrical engineering major at Western Illinois University, Quad Cities.
And I'm Christian Trochet. I'm a mechanical engineering major at Western Illinois University.
So why did our group choose a water level indicator circuit? Water level indicators have many important and real world applications that will be touched on a little bit more later in our presentation, but just think like groundwater systems and hydrology systems. The circuit was also complex enough to be a little bit of a challenge figuring it out, but simple enough to understand and modify to fit our needs for this project. And a water level indicator circuit combines aspects from the 3 engineering disciplines that our group is comprised of. Electrical, obviously, seen in the design and building of the circuit itself. You see mechanical engineering in the design and building of the components that went into the circuit. And you see civil engineering through the fact that water indicators are used in many infrastructure systems around the world. Our design objectives for the circuit. The first one would be that we wanted to combine our knowledge from our Engineering 271 circuits class from our labs and lectures, along with research that we did on other water indicator schematics to create a working circuit. We wanted to create a circuit that will alert by lights when water reaches 4 distinct and predetermined levels, with a buzzer that would also alert the user if they miss the lights when the water reaches the highest level. We chose a circuit to show how basic circuit components can be used and combined to create a multi-part system.
So a little bit of theory and background. Water levels relay information using sensor probes or wires into a storage tank or a defined container, which then send the information back to the circuit and produce light and or sound. And then in our case, we chose to do light and sound. Water level indicators, like mentioned before, are important in real world applications. For example, detecting leaks or potential leaks in factories. They act as a warning system to monitor potential flooding. They're useful in geological surveys for groundwater management, as well as keeping track of Earth's trends over the years and for future predictions. So 2 main types of water level indicators would be non-contact sensors, which use measurement methods that don't require components to be placed directly into the water. And this can be achieved through the use of ultrasonic sound waves. And then the other type would be contact sensors, which is what we created. And this would be the oldest and most common type of water level indicator, which would then involve the direct contact with the water to take those measurements. And then a water level indicator circuit does not have to be very complex to achieve your goal.
The materials that we used are 4 1000 ohm resistors, 4 300 ohm resistors, 4 BC547 transistors, which are the most important component of the circuit, 4 different colored LEDs, jumper wires, a buzzer to give us the sound alert, and a 9-volt battery to power the circuit. So how our circuit works is, as I said, the most important part is the BC547 transistor, which acts like a gate for current. And how it works is it has 3 pins. The collector pin, which is usually connected to any elements of the circuit. We have the collector pin connected to one of the 3000 or 300 ohm resistors, the LED, and a jumper wire to the positive terminal. The base, which we have connected to the 1000 ohm resistor and to the reference wire. And then we also have the emitter, which is connected to just our negative terminal. And then we have all that connected to a 9-volt battery. And how the circuit works is we have the reference wires at 25% capacity, 50% capacity, 75% capacity, and 100% capacity. With the buzz, once the water reaches the 100% capacity, the buzzer will sound. And how this works is the base pin of the transistor acts like the key, and it opens the gate when there's current supplied to it, and the gate is closed when there's no current supplied to it. And so how this works is we have a base wire that is at the very bottom connected to the positive terminal, and as the water rises and connects the reference wire to the base wire, the current flows through the reference wire, through the resistor, into the base, opening the gate and allowing current to flow to the emitter, therefore closing the circuit and turning the LED on. And we have each one of those reference wires connected to each of the different levels in parallel, so that as the water rises, you can see each LED turning on. And we have a video showing how that works in the next slide.
For future changes, we can make our water level indicator portable. We can do this by transferring the circuit we have on the breadboard onto the pink plastic as seen on the screen. And it would serve the same purpose, which to measure the level of the water. We would make the circuit much cleaner by soldering everything nicely together. And now, one thing is, now depending on the depth of the container, the water is to be measured. It would make the reference wires, the length of the reference wires change. This would allow us to use our water level indicator anywhere and at any depth desired.
Yeah, so in conclusion, we have discussed a simple yet effective water level indicator circuit using a 9-volt battery, resistor, transistors, LED lights, and a buzzer. The water level indicator circuit we've shown is designed to provide a visual and audible indication of the water level in a tank or reservoir. The circuit that we have developed here is straightforward and can be easily constructed by anyone with basic knowledge of electronics. The circuit shown, as discussed, uses a series of resistors and transistors to detect the water level and activate the LED lights and buzzer accordingly. The LED lights flash every 1/4 filled until reaching full, while the buzzer sounds when the tank reaches its maximum capacity. The water level indicator circuit has several benefits. Firstly, it helps to prevent overflows and water wastage, which is critical for water conservation. Secondly, it ensures that tanks and reservoirs are always at optimal levels, which is essential for maintaining water supply for domestic and agricultural purposes. Lastly, the circuit is cost-effective and can be easily installed in homes, farms, and other applications where water storage is necessary. By using the water level indicator circuit, we can ensure that we are doing our part to conserve this precious resource and ensure that it is available for future generations. Please leave all questions, comments, and concerns at the bottom of this video presentation, and we look forward to answering them shortly. Thank you.